Hello everyone, this is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering at Department of Electrical and Electronics. Today the topic I have chosen is air core coil. How does an air core coil works and what are its efficiencies, losses and core permeabilities and reluctance. Let us know in further slides. First, what is an air core coil? Let us know about it. A air core coil is an essential component in various electronic circuits. This presentation delves into the fundamental characteristics, advantages, disadvantages, applications, and design considerations. First thing, what is a coil? A coil is a copper wire which is twisted or turned into a round shape through two terminals. It is known as air core coil. It is used in various electronic circuits to present the fundamental characteristics of it. Introduction to air core coil. The basic definition is an air core coil is an inductor. When a copper wire, we know that when a copper wire is twisted into a coil, it is an inductor. It acts as an inductor uh, that uses the core material. It consists of a wire wound into a coil shape with an ferromagnetic material in the center. Yeah. Operating principle is when an electrical current flows through a coil, it creates a magnetic field around it. The inductance of the coil is determined by the number of turns and coil diameter and spacing between turns. As we all know that a copper wire is twisted into a coil, then it is an inductor. So the inductance is present in the coil, and the inductance of the coil depended upon the number of turns as we twisted, and the coil's diameter and the spacing between the turns. If the space is more, then the flux losses are also more. Now let us know about advantages of air core coil. High frequency performance, stable inductance, low cost. High frequency performance. What is mean by high frequency performance? And high frequency performance is excel like frequency application due to an absence of core losses, allowing the material minimum energy dissipation. When the twisted coil has a high frequency losses according to its performance and the copper ratings, and it has a stable inductance when the coil shape and size is with equal number of turns. The inductance of a air core coil remains relatively stable over a wide range of frequencies and temperatures, ensuring consistent performance. It is low cost. The air core coils are often more low effective component ferromagnetic cores, especially smaller sizes. It is low cost because the air core coil doesn't have any core. It is already known that it is an air core coil. Air core means it doesn't have any core, so it is very low cost. Disadvantages of air core coils. The We know that the air core coil is having no core of permeability. If the core is present in the air core coil, then the core should be having low reluctance path, because the inductance or the magnetic field should be passed around the coil. Disadvantages of air core coils having low inductance, high power laminations, large physical size. Yes, these air core coils are having low inductance because when there is no iron material which is present, which is low reluctance iron material present at the middle of the coil, so automatically it has low inductance. For a given size, air core coils typically having lower inductance compared to the coils with ferromagnetic cores. We can clearly know that here the ferromagnetic cores are not present in the air core coil, so it is having low reluctance and lower reluctance and inductance. High power laminations, due to their lower inductance, air core coil are less suitable for applications and require high power handling. Yes, because there is no core in the present in that, the ferromagnetic cores present in that, the air core coils are used for lower inductance and less suitable for applications which is required for high power handling. So it is not more likely suitable for the high power handling material. It is just having low inductance of the stable application is that it is having low inductance and it is less of high power handling. Since these are the two disadvantages of air core coil, coming to the third one, large in physical size. Yes, air core coil, it is purely copper wire twisted into the size, so it is very large and very heavy to lift or handle than its disadvantages. To achieve the desired inductance value, the air core coils are also having the larger physical dimensions compared to the core coils. Yes, the air core coils is having larger physical dimension compared to the core coil. The air core coil is more in size and more in what we call the weight than the core coils, because the core of the inductance is related to the magnetic flux and the flux leakages. So these are the all types of disadvantages of air core coils. But the air core coil main purpose is used that to show the inductance and flux losses between them. And coming to applications of air core coils, these applications of air core coil are generally in a wide range with what we use, and they are also having the air core applications of radio, antennas, and medical equipment. Let us know one by one. Radio transmitter and receiver. Air core coils are widely used in RF circuits, particularly in radio frequency oscillators and filters. Yes, radio frequency oscillators and filters. These air core coils are widely used in RF circuits, means radio transmitter and radio frequency circuits. Then the oscillator and filters are also used in this by the air core coils. Alternators. Air core coil from a basic of various antennas of air core coil also basic varies from antennas design enabling efficient signal transmission and uh, res- reception. These are having efficient signal transmission and they can also equip and they can also give medical equipment. They are essential for the medical equipment which are following, allowing the precious value of membrane generation of diagnostics. These air core coil are also having the essential of allowing prescriptions and also generation of diagnostics. These are all the applications of the air core coils. And let us know now design considerations of for air core coil. The design considerations of air core coil is coil winding, coil shape, shielding. These are the three types of design configurations considerations. Let us know one by one. Coil winding. The number of turns wire gauge and the space between the turns influence the coil's inductance and its ability to handle the current. Yes, absolutely. If the coil and also is the coil is twisted and it is the inductance of the coil is generally depend of the upon the number of turns and the stability to handle the current, number of turns and length of the coil. It decides the inductance of the coil. Coil shape. Different coil shapes as such as solenoids and toroids affect the magnetic field distribution and inductance. Shielding. Shielding the coil can maximum interface from the fields, improving the performances of different types of shielding can minimize the coil copper length and improve the performance. Coming to factors affecting the performance of air core coils. There are three factors that affect the performance of air core coil: frequency, temperature, humidity. First one, frequency. The coil's inductance can vary with frequency influencing its impedance and performance. Next one is temperature. Temperature influences can effectively the coil's inductance, potentially impacting the circuit operation. Humidity. High humidity levels can lead to corrosion and the composition of its performance. So these are the factors affecting the performance of air core coils: frequency, temperature, and humidity. And coming to comparison with other types of coils, the air core coil is starting and ferrite core and iron core. These are the First comparison is air core coil and next ferrite and iron core. Air core coils offers advantages of high frequency applications with ferrite and iron cores coils providing higher inductance and prove power handling, but it is but with laminations in frequency response. The frequency response of the air core coil is generally on the higher inductance and powered handling, but the laminations of frequencies with air core and ferricore proportionally to iron core. So these are the comparisons of other types of coils. The conclusion and summary: air core coils are valuable components in numerous electronic systems. Their advantages and in high frequency applications make them ideal for the radio, antenna, and medical equipment applications. Understanding the design considerations and laminations enable the engineering and optimize the various circuit programs. Yes, these are advantages of this is the high frequency coil makes them the radio, antenna, and medical equipment. These can in future generations, these can future enhancement, these also can consider the laminations of enables engineering optimization of various circuit designs. So this is the conclusion of the summary. Hope understood about the air core coil applications, advantages, disadvantages, and fuel for further future enhancement. Conclusion and summary we have already discussed. Thank you. Thank you.